California, catastrophe strikes on one of America's biggest bridges.
I felt the bridge going sideways. Oh, we're having an earthquake. We're having an earthquake, folks. Hang on.
In Texas, homes on the brink of disaster.
One of the residents called 911 and reported that his backyard was sliding down the hill.
A Manhattan skyscraper causing supersized problems.
Cables were causing the elevator to stop. There was one instance in which a resident was stuck for more than an hour.
And a narrow escape in New Zealand as a stadium collapses in seconds.
There was a real loud bang, and the next minute, all hell broke loose.
With big builds, even the smallest fail can trigger a huge disaster. From miscalculations to misunderstandings, or just plain bad luck. These catastrophes are every engineer's worst nightmare. Engineers are constantly battling the might of Mother Nature. Her massive forces can strike at any time with devastating power. Like this catastrophe in California that was witnessed by viewers across the nation.
It was only a matter of seconds, but it felt like a lifetime. The world saw the city collapse.
As a devastating earthquake wreaked havoc on an iconic bridge.
To see a chunk of it falling off, it seemed like a movie, and it was just shaking itself apart.
A tragedy that left drivers fearing for their lives.
To me, every second on that bridge was, how could I save myself?
San Francisco, California, is one of America's most iconic cities. News photographer Carlos Gonzalez has always felt the lure of the city by the bay.
It's one of those places that just embodies sort of a magical feeling about it. This is where I wanted to be, in San Francisco.
With the city surrounded on three sides by water, life here depends on two epic bridges.
The Golden Gate Bridge is without doubt one of the most famous crossings in the world. But the real workhorse in this city is the mighty Bay Bridge.
This gargantuan feat of engineering is one of the busiest bridges in the nation, carrying around 100 million vehicles a year. Bart Ney is head of public affairs for the California Department of Transportation, Caltrans, and knows the might of the Bay Bridge firsthand.
Well, San Francisco Bay Bridge is a vital transportation link for the entire state of California. For example, when we take this bridge out of service, which is almost never, we have to let the entire state know.
And there's much more to the Bay Bridge than the suspension span you see from downtown.
The easiest way to understand the Bay Bridge is to think of it in really two parts. It's several different bridges, but two different parts. A western part where we are right now, which is made up of two suspension bridges and an approach that goes down into San Francisco, and an eastern part that touches down in Oakland.
This eastern section carried traffic toward Oakland for more than 50 years. At the time of its construction in the 1930s, this was the longest span of its type in the nation. But it was just one link in a much longer bridge.
The eastern span had a vast cantilever span bridging the ship channel, but about 3/4 of the bridge was built more like a long causeway over the shallows leading to Oakland.
The old eastern span of the Bay Bridge is completely different than the modern new one that you see out there today. It was almost all steel. Driving through it was almost like flying through the Death Star trench. It really evoked the period of time that it was built in. It was a masterpiece of steelwork.
But in the late 1980s, this steel colossus encountered an unstoppable force that would shake it to its core. October the 17th, 1989. It was Game 3 of the World Series, and for residents like Bart Ney, This was a must-watch event.
I was working on my boat and I needed to take a break because the A's and the Giants were playing. It was an amazing thing to see both of our Bay Area teams in the World Series.
You have the teams from each end of the bridge going up against each other. It's a huge rivalry. In fact, this was known as the Bay Bridge Series.
Shortly before 5 p.m., Suzanne Lee was on the approach to the Bay Bridge, heading home to catch the game.
I got on the ramp and got onto the bridge and looked around and thought, whoa, this is great. The traffic is so light. This is really, like, perfect.
But Suzanne's perfect commute was about to hit a major roadblock.
It felt like the car was having 4 flat tires. And when I looked around, the other cars were starting to, like, drive, like, wobbly. And I thought, oh my God, they must have 4 flat tires too.
This was no multiple blowout. The bay was under attack from below. At 5:04 p.m., a magnitude 6.9 earthquake rocked the city. Like millions of baseball fans, journalist Carlos Gonzalez watched the scenes unfold live on screen.
Everybody was glued to their television set and watching. It was just terrifying because you had the TV on and you could see what was going on.
On the Bay Bridge, Suzanne was caught in the heart of the disaster.
I had the radio on. I heard, oh, we're having an earthquake. We're having an earthquake, folks, hang on. And I then just realized I didn't feel 4 flat tires. I think I felt the bridge going sideways.
A section of the upper deck had collapsed, dislodging the deck below too.
The first shots that you saw, I just couldn't believe that something like that could possibly happen.
Everything came to a total stop. And then there was that swinging feeling. You heard a couple of people scream, and then quiet, then quiet.
Suzanne was trapped on the lower deck.
Nobody knew what was going on because we were just stuck.
Just the amount of devastation and the immediacy of that moment, seeing it happen live was shocking.
High above the bay, Suzanne was desperate to escape the bridge.
How could I save myself? If the bridge is going to go down, if I just stay in this car, I'm just going to sink.
It seemed like a movie, right? A science fiction movie, not something that would actually happen.
With the route ahead blocked, drivers were forced to slowly back up off the bridge. A terrifying ordeal that lasted around 5 hours.
Quite frankly, I don't know how we got off the bridge, even within 5 hours. I guess I just started to count my blessings that I was okay, but it was scary. It was definitely scary.
The World Series caused traffic to be light, likely reducing the disaster's fallout. But one car plunged through the gap. Although severely injured, the passenger survived. But tragically, the driver didn't make it. The earthquake was one of the worst disasters in the bay's history. 3,700 people were injured and 63 lost their lives, all because of an earthquake that lasted just 15 seconds.
We have a major injury accident, Cypress and West Grand. They're advising major injuries.
15 seconds sounds like a short amount of time, but it's a long time for the Earth to move.
The most terrifying thing is you just don't know when it's going to stop. It was only a matter of seconds, but it felt like a lifetime.
The quake caused an estimated $10 billion worth of damage, including cutting off the area's most important crossing.
The Bay Bridge carries around 280,000 vehicles a day. It's a vital link, not just for the city, but the entire state.
As the city reeled, the public began asking questions. This bridge had been built to withstand earthquakes, so why had it failed? As Caltrans Chief of Public Affairs Bart Ney explains, the disaster exposed a weakness lurking within this supersized structure.
The old eastern span, as it was originally constructed, is a bunch of different steel truss bridges that are connected together at joints.
This pier, known as E9, was where the causeway-like deck of the Oakland side joined the through-truss steel lattice, heading for Yerba Buena Island.
So if you're going to join two bridges and you know, gosh, there's so much steel in it, they're going to expand and contract, let's give a little play at this location.
The more than 3-kilometer-long eastern section held several of these so-called expansion joints.
The ends of the decks sat on ledges or shelves so that they could slide back and forth a little. Those expansion joints also doubled as earthquake protection, allowing the bridge to move with the shock waves.
At each joint, dozens of massive bolts would allow movement, but prevent the decks from sliding off their shelves.
At this location, we could accommodate between 4 and 6 inches of movement, so that should an earthquake happen, we're going to be okay. That's a pretty big span for steel just to expand and contract.
But when the biggest quake in 80 years struck, 15 centimeters just wasn't enough.
Once the motion of the bridge caused it to go beyond that, the bolts just weren't strong enough to hold the bridge together.
The deck section was pulled off of the expansion joint, and it dropped like a trapdoor.
As investigators dug deeper, they discovered that some piers had moved much more than anticipated, for reasons unknown by the original engineers.
The eastern span mostly stands on clay and mud. When this earthquake hit, that ground became soft and almost liquefied. So you've suddenly got these deep supporting piles moving around all over the place.
Engineers now know that the soft ground around the piles amplified the shock waves, a phenomenon which would not occur on solid rock.
The pile foundations had lost the tension that they need to hold the bridge in place, and it was just shaking itself apart.
Yet the disaster was mitigated by one stroke of luck.
One piece at Pier E9. It's about 76 feet wide, about 50 feet long. The weight of that landed on the lower deck, and that unhinged the lower deck section, and all of it was pinned in on an electrical substation that was located directly underneath. Had that substation not been there, those pieces would have continued down to the water.
While one driver tragically died, experts believe if the collapsed section had fallen into the bay, more fatalities would have occurred. The city was in mourning, but the Bay Bridge was a vital link that needed to be fixed fast. Engineers went to work, and the broken section was repaired just a month and a day after the earthquake.
For it to take a month was an engineering marvel. The Bay Bridge was back up and running again, which is still incredible to this day.
But engineers knew they might not be so lucky if another quake struck, so they began planning for a truly state-of-the-art replacement bridge.
We had to build something that would withstand the largest potential earthquake in 1,500 years. It also had to be iconic. It had to be something that people looked at and felt inspired by.
Earthquake engineering had come a long way in 9 decades, and the result was this: a $6 billion shockproof bridge. Not only does it feature the world's largest self-anchored suspension span, but the entire East Bay section can handle more than 10 times more seismic movement than the original.
With this new eastern span, we can accommodate over 6 feet of movement in different locations. Everything we could imagine, everything we could put in, everything that we could stretch for technologically, seismically, is in this span, and it's beautiful. But we're mostly relieved that it got here before the next earthquake.
It's only a matter of time before another quake strikes this iconic city. But when it does, this vital lifeline will be prepared to withstand whatever Mother Nature throws its way. In engineering, where you build is just as important as how you build. Get either wrong, and the results can be disastrous. Like this catastrophe in Texas that struck a suburban neighborhood.
It looked like a sandcastle that some bully had come and kicked over.
Putting homes on the edge of disaster.
The ground is all ripped and torn up, as if there's been an earthquake.
It was just devastating to me because I didn't know what was about to happen. Everybody was in shock.
An event that left a community asking, what had gone so wrong? There's a famous saying in the Lone Star State, everything's bigger in Texas. And that's true for those living in San Antonio, who can see their city growing every year. Sean O'Neill is a journalist and Texas native.
So people like to say San Antonio is a big city with a small town feel. Will Rogers famously called it quaint, you know. It's unlike Dallas or Houston, it's still sort of got this intimate small town vibe, even though it's, you know, the 7th biggest city in America. With the population boom of 2020 and 2021, it's fast overtaking Philadelphia to become the 6th.
And one thing this new wave of San Antonians all need is somewhere to live.
Right now, the housing market is exploding in San Antonio. There's been this need to annex that land at a really rapid pace, and that's really picked up, especially in the last few decades. And with that comes a lot of building on land that wasn't necessarily meant to house large subdivisions.
This is one of those new subdivisions in northwestern San Antonio. Javiera Arana Johnson is a former resident.
River Mist, I felt like it was a really nice place to live. It was my first home, so I had a lot of dreams and a lot of different things that I wanted to do with the house. Nice, sweet community. All the people were really close. I really enjoyed living here.
Javiera's home was one of 300 new houses built on the undulating ground.
When you're building, ideally you want to do it on a flat, stable surface.
If the terrain is uneven, like the hills of River Mist, one option is to use massive amounts of soil to create a flat surface. Then you need to make sure it all stays in exactly the right place.
In River Mist, that called for a giant retaining wall. Dr. Jack Leifer is an associate professor of engineering.
A retaining wall is a structure that allows differences in elevations to be held and maintained. They literally hold back the soil. We have some soil, and we have this wooden board that serves as a divider, maintaining the difference in heights between the two sides of the soil.
Retaining walls can use deep driven pilings or cable systems to hold them in place. But here, they went for a gravity wall.
Essentially, you build a wall using heavy blocks which use their own weight to hold back the soil.
Crucially, the wall needs a wide base to prevent the soil it retains from knocking it over.
So the wall has to be both heavy and it has to be wide enough on the bottom to resist the rotation of this wall.
By 2008, the hills of River Mist were home to more than 400 people living out their American dream. Until one quiet Sunday morning, when that dream became a nightmare. January the 24th, 2010, Javiera Johnson was driving home from town.
On my way back, my mom and my dad called me and they said that hurry up and come back. So I tried to rush back over here.
Pulling onto her road, she was greeted by roadblocks and police tape.
Police and the sheriff department and also fire department.
Her road was closed off, as was her home.
They told me that I have to evacuate my home because there was a wall collapse and they were afraid that those top houses were going to fall to the bottom.
River Mist's 12-meter retaining wall was crumbling, right on top of Javiera and her neighbors' homes.
One of the residents called 911 and reported that his backyard was sliding down the hill.
What I saw when I came back, there was actually like crumbling, and then you could see like the inside dirt and rocks is what you can see.
Imagine watching the land around your home just falling apart. It must have been horrific.
It looked like a sandcastle that some bully had come and kicked over.
With the situation out of control, authorities determined that the whole street was at risk.
At the rate that the slope was deteriorating, I can only imagine that the residents, once they left these homes, they probably weren't certain that it was still going to be here when they got back.
Everybody was in shock. I couldn't even think of what to grab, what not to grab. I don't even have time to be able to gather things.
With their homes uninhabitable, residents were forced to ask what had caused the disaster. Analysis of the damaged site found the culprit could be the very soil the wall was designed to hold back.
In the weeks leading up to the failure, the area had seen heavy rainfall, and it seems the waterlogged ground behind the wall had started to expand.
A process that over time was causing serious problems, engineering professor Dr. Jack Leifer explains.
The soil at the River Mist location was what we know as clayey soil, and that's the way you say it. It's clay-like. Clayey soil accumulates water, and that puts enormous additional lateral pressure onto any sort of retaining wall system.
As the soil absorbed heavy rainfall, it expanded like a sponge, causing cracks in the masonry that was holding the retaining wall in place. And the damage was about to get worse.
When it dries, it recedes and it retracts. So now you may get separation between the soil structure and the wall.
As the dried soil pulled away, the weakened wall was left unsupported. And it was only a matter of time before it failed. But the soil wasn't the only factor. The type of retaining wall might have played a part as well.
First of all, given the height of the wall, you may have wanted to consider something other than a gravity wall. From an engineering perspective, a successful gravity wall has to have both weight and it has to have girth at the bottom.
Engineering is all about compromise, striking the right balance between strong enough to do the job, but not so strong that you're wasting time and materials. And sometimes the balance is off.
The investigation also revealed that the wall was lighter and narrower than originally designed.
Any small changes, even if they're seemingly harmless, can drastically change the loads on a structure and can cause that structure to fail.
Although the reasons for the design change remain unknown, the failure of the wall had far-reaching consequences.
It was like 80 total homes at first that they said were possibly affected. It was a complete disaster.
Javiera's home escaped unscathed, but the risk of the wall further collapsing left the authorities with no choice but to prevent Javiera and her neighbors from returning.
I had fully furnished my house. To me, I'm thinking the furniture, all my belongings, everything, like what's gonna happen, but we weren't allowed.
Nearly a year after the collapse, work began on a new retaining wall right downhill of the original. This time, more than just gravity would hold it in place.
The original wall is still there, and that provides some additional support, but an additional wall was built, and that wall consists of pilings that are drilled down very deep with sections between the pilings.
The new wall has concrete piers driven up to 6 meters into the ground, with steel pins supporting the whole structure.
So whatever happens, this wall won't be going anywhere.
The piling wall is buried more deeply, and it's more stable because the lower you bury a structure, the more stable it's going to be.
7 months later, the new retaining wall was in place, but Javiera and her family had made the choice to leave.
I really hope that the new wall that they have, I hope and pray that it lasts and that it works well for this community, because I would never, ever in my life want anybody to go through something like that.
I mean, it's like a metaphor, right? You're really living on a precipice. So there's the implication when you live on a precipice that things could all literally go downhill at any moment. You could fall off the edge.
For engineers, pushing the boundaries to create iconic structures means taking big risks. But sometimes the risks can outweigh the rewards. Like this story in New York, a pioneering skyscraper that hit the headlines.
There were reports of it creaking like a ship at sea.
An iconic structure plagued by unanticipated issues.
This pressure would cause loud banging noises that, I quote, sounded like a bomb.
A super tall skyscraper causing supersized headaches for residents.
Cables were causing the elevator to stop. There was one instance in which a resident was stuck for more than an hour.
Getting stuck in a lift is some people's worst nightmare. Imagine that happening 80 stories up in a super skinny skyscraper.
New York City, a financial, commercial, and cultural powerhouse, is also home to some of the finest skyscraping structures on Earth. Former resident Stefan Al is an architect and skyscraper designer.
New York is one of the greatest cities in the world. I think it's an example of what we can achieve as a civilization, building greater and greater up in the sky, but also bringing people together from all over the world into a relatively small space.
The Manhattan skyline is possibly the most iconic in the world. Engineers have been building here higher and higher ever since the 19th century.
Sean Corsandi is an associate professor of architecture.
Historically, towers are about ego. They're about eminence, they're about attitude. And that's why it was so great to be building tall and getting things in New York like the Chrysler Building or the Empire State Building. That had a civic pride. It was sort of something for the city to look forward to, an engineering feat, and it's something everyone could enjoy.
In recent years, the ranks of commercial and civic structures have been joined by super tall residential towers. Stefanos Chen is a real estate reporter.
In the last, say, decade or so, we've seen most of the new skyline that people most recognize is this new residential condo development. So all along 57th Street, which is now called Billionaires Row.
So Billionaires Row is right over there on the south side of Central Park, where we see these extremely skinny, super tall skyscrapers that contain these luxury apartments.
This tower on the southeast corner of Billionaires Row was the game changer. The 426-meter-tall structure is home to more than 100 luxury apartments, most with prime views of Central Park.
What's driving a lot of this development is the view. You can have lots of things in New York, but a protected view is very hard to come by.
Because they're so close to Central Park, the taller you go, the better your view of Manhattan's most famous park.
And the better the view, the higher the price tag.
The higher you can go, the higher the premium is per square foot for these condo apartments. The record currently is more than $13,000 a square foot.
Key to those eye-catching views is the tower's super thin profile.
The thinner the tower and the bigger the windows, the better the view from all over your apartment.
Well, the first thing that stands out when you look at this model is that it's extremely skinny for a skyscraper. So 432 Park Avenue has a slenderness ratio of 1 to 15. That means that it's 15 times taller than it's wide, right? Which is very different from the early generation of skyscrapers.
This tower is insanely skinny. The base is the size of just 2 basketball courts, but it is structurally taller than the Empire State Building.
When building tall and thin, engineers take on not just gravity, but the power of the wind, which applies lateral pressure to the tower.
The building wants to swing left and right in the wind. It needs to transfer it to this very narrow base. That makes them a real technical challenge.
Engineers used a clever trick to reduce the wind pressure on the building. 5 double-height stories with no windows, known here as mechanical floors.
If you look at these mechanical floors, they're completely open so that the wind can blow through them, so that reduces the wind pressure on the building.
But allowing the wind to blow through only reduced part of the sway. engineers also installed massive weights near the top.
On the upper stories, there's what we call tooth mass damper, which is a very large counterweight, hundreds of tons heavy. And every time the building sways this way, this counterweight will move in the opposite direction to kind of balance out the swaying.
Upon completion, this high-tech tower was the tallest purely residential building in the Western Hemisphere.
You had not only the best views in the city for a period in time, but also some of the highest prices in New York City. There's currently the penthouse apartment listed for $169 million, which works out to something like $20,000 a square foot, which would totally break the record currently in the city.
However, soon after residents moved in, it appeared that all was not well with the luxury lifestyle. Stefanos Chen broke the news.
We first heard about the story from a resident who had reached out with some complaints about construction defects in the building. Some of the biggest issues were water damage. There were several plumbing leaks that caused essentially millions of dollars in damage.
The reported problems went much deeper than water leaks.
You have issues of sway as well. Basically all buildings sway, but when you get that high up in the air, it's really noticeable. Some folks had even told me that they were feeling seasick.
All tall buildings sway. It's just a question of how much, and whether the movement does more than make you feel queasy. Here, there were reports of it creaking like a ship at sea with banging noises.
Noise really has been a major complaint with some residents. There are whistling sounds, creaking sounds, all sorts of things that you wouldn't expect when you're paying top dollar.
As if swaying, creaking, and banging weren't enough, there was one more disturbing problem.
Because of the height of these towers and the way in which the building sways at that height, cables inside the elevator shaft were sort of slapping against the side of the shaft and causing the elevator to stop. So there was one instance in which a resident was stuck for more than an hour.
Getting stuck in a lift is some people's worst nightmare. Imagine that happening 80 stories up in a super skinny skyscraper.
It's sort of hard to relate with multimillionaires to that degree, but I can't imagine anyone really being pleased with paying that much money and getting an apartment that just is riddled with defects and issues. Everything which might have been a minor inconvenience for smaller buildings becomes that much bigger in super tall.
One of the world's tallest towers was hitting the headlines for all the wrong reasons, and people wanted to know why this state-of-the-art structure was rocking.
The taller you build, the more a building sways. And a little sway is good. If a building were completely rigid, it could break during a seismic event. So having a little bit of sway is good. The problem is that there's human limits to what amount of sway is comfortable.
Although key to the structure's safety, that sway also caused the elevator's habit of grinding to a halt mid-ride.
If the building sways too much, it can damage the elevator and it can be a safety hazard. So sometimes this is deliberate that the elevator will pause when the building sways too much as a safety precaution.
But sway wasn't the only problem concerning residents, who also reported hearing banging noises. That could be caused by another air-induced problem, the so-called stack effect.
When it's cold outside, the warmer air on the inside rises, creating a buildup of pressure that looks for somewhere to escape, which in a super tall building like this could be the elevator shafts or the garbage chute.
If you would open the trash chute, right, which is a shaft that goes all the way down, I can imagine that this pressure differential would kind of cause loud banging noises that I quote, sounded like a bomb.
Ultimately, residents needed to know exactly how deep the problems went.
So the residents commissioned an engineering report and the results were pretty alarming. They had found that over 70% of systems in the building were not as promised, and that there were several safety concerns.
The developers have stated that none of the issues are safety critical. And while the dispute with residents and owners continues, one question is, can the sway be resolved?
So I'm sure there's ways to remediate some of the issues. The trash chute issue as well as the flooding issue should be able to get resolved. The sway issue, on the other hand, will be much harder problem to solve, especially for the upper stories. And to solve something like that, you really need to change the structure or the tune mass damper, which is a lot harder.
Problems escalate as we keep amplifying and building these buildings even larger. This building has already been surpassed by other buildings on this very block. And if the issues are not solved here, they escalate and amplify.
In the end, many believe problems like these are inevitable in the drive to build ever taller.
This is the first time they built a residential building this tall, and if you look at the history of skyscrapers, there's always problems that emerge because technology has to catch up with innovation.
The truth is, pushing the boundaries in engineering always comes with risks. If architects didn't try, our cities and skylines wouldn't be as iconic as they are today.
When building big, engineers are in a constant battle with the elements. But sometimes the forces of nature can't be stopped. Like this disaster in New Zealand, which destroyed a stadium in seconds.
Next minute, all hell broke loose, basically.
The city's pride and joy went up against Mother Nature and lost.
It was chaos when I walked up here. You could see the front side of the building had tipped in.
Revealing a decade-old weakness and sending shockwaves across the community.
How in God's name are we ever going to get this back?
New Zealand's Southland region. This remote, windswept landscape seems more suited to sheep than people.
New Zealand sits right in the path of powerful winds that whip around the southern hemisphere, known as the Roaring Forties. And right at the far southern tip, the Southland region is exposed to some of the toughest weather in the country.
That includes Invercargill, one of the most southerly cities on Earth, home to a tough community bonded by a love of sports. Nigel Skelt manages the city's only stadium.
We are sports mad. We have a fraternity that are crazy, that follow our international franchise sport, and just a very, very close-knit community.
Invercargill experiences unpredictable weather. So in 2000, Stadium Southland opened to make sure the city never missed a game.
There was a massive campaign from the public who really bought into it, and some of the sports bodies and the schools. It was very much a community-driven project.
More than 9,000 square meters of the stadium is dedicated to 9 courts, accommodating multiple sports under one giant roof, supported by steel trusses.
Trusses are used everywhere from bridges and cranes to stadiums. They're effectively a self-supporting steel lattice that's perfect for spanning long distances without needing extra support in the middle.
It's amazing engineering. When it all comes together, you end up in a covered space the size of a football field.
When the stadium opened in May 2000, it scored an immediate win.
Sport grew in each and every angle almost instantaneously from that day, so it was fantastic.
For a decade, the stadium hosted sports as well as concerts and events, regardless of the weather, until early spring of 2010. September the 18th. A huge snowstorm was rolling into Invercargill. Safe inside the town's stadium, coach Kieran Fahy was putting tennis students through their paces.
Some of the junior players needing a bit of help with doubles tennis and stuff like that.
At 10:45, as the snow fell faster, the decision was made to cancel the class.
So they thought, right, we get out of here before we get snowed in and can't get back home.
Families gathered in the foyer and prepared to brave the weather outside, but Kieran stayed inside.
There was a real loud bang, and then it's something that felt like a hurricane, going past.
But this was no hurricane. Just after 11 a.m., disaster struck.
Next minute, all hell broke loose, basically.
The stadium's roof had collapsed. Operations manager Ryan Sycamore was first on the scene.
It was blatantly obvious. When you walked up, you could see the front side of the building had tipped in. It was just terrible.
Ryan called his boss, stadium manager Nigel Skelt.
I called him and I just had to say, the building's collapsed. You know, it's all falling down.
When Nigel arrived, the damage looked unsurvivable.
It was horrific from the corner. There was a concertina effect from there. The roof coming down at different spaces throughout.
No one had yet realised that Kieran was still inside.
When the roof came down, it just blew the emergency door wide open and anything that was in the passage just was thrown out like toys.
Kieran's survival was a miracle, and the city's luck didn't end there.
Normally, on any weekend, we are incredibly busy. We only had a small group of tennis players that morning, and the good fortune very simply being no loss of life.
But Invercargill's pride and joy lay in ruins. Why had a stadium designed to withstand the region's extreme weather collapsed after just 10 years? A detailed investigation was launched, and the first culprit seemed obvious: the snow. Structural engineer Ashley Smith was on the investigation team.
Structures of that type normally have quite a large safety factor, and we felt that it was more than just the snow that would have caused that collapse.
In fact, on the day of the collapse, the pressure from snow was only 75% of the roof's design load.
During the investigation, the team calculated that the probability of snow alone causing the collapse was less than 1%.
Further analysis of the wreckage revealed a weakness in one steel roof truss at the eastern end of the stadium.
This is showing one of the trusses that collapsed. You can see a sharp kink at that point.
The cause was tracked back to the initial construction a decade earlier, when the truss started to deform.
They were installing roof materials and ceilings and various other things, adding more weight onto that roof and realising that there was too much deflection in that truss.
Deflection in a truss is essentially sagging. Every truss is expected to sag a little bit, but too much is a sign something is wrong.
As more weight was added to the truss, it deflected, ripping the concrete top from the supporting column, along with the anchor bolts embedded in it.
That was the reason for the excessive deflection, because that connection couldn't hold that truss in that rigid arrangement, so not strong enough to do the job.
For unknown reasons, the column wasn't repaired or the bolts replaced. Instead, the construction team decided to straighten and reinforce the truss.
First of all, they put some jacks underneath the trusses and jacked it above its original alignment. So when they jacked it up, they had to infill that with a steel plate and weld it back together. And then they added these side plates on the trusses on those red lines to strengthen it, to stiffen it really, before they let the jacks go.
Although the team didn't know it at the time, the fix hadn't worked. The unsuccessful repairs to the truss were the stadium's Achilles heel.
With the excessively heavy snowfall, the welds in the strengthening plates failed, the truss buckled, and with no solid anchor holding it in place, it slipped off the columns.
As it fell, it dragged the rest of the roof down with it in seconds, just like a house of cards.
The 2010 collapse was a near miss for the people of Invercargill, but it also brought the community closer together as they rallied for a new and improved stadium. The new roof has redesigned columns, a more robust concrete mix, and deeper, stronger trusses.
The stadium today can support 76% more snow loading than the original design. Ready to take on any weather the roaring 40s can throw at it.
Oh, I think the stadium is basically the heart of the city, really. I wouldn't swap it for anything. I wouldn't swap it for anywhere else.